Hello. In this video, we want to start looking at a test for increasing and decreasing. So suppose the function f has a derivative at each point in an open interval, then f prime of x is greater than 0 for all x in the interval, and f is increasing on that interval. If f prime of x is less than 0 for all x in the interval, then f is decreasing on that interval, and if f prime of x is equal to 0, for all x in the interval, then f is constant on that interval. Okay, so here's the thing. We really want to look at where the derivative is greater than 0 to show where the function is increasing, and where it's less than 0 to show where it's decreasing. And therefore, if it's 0, it's flat, which means that it is constant in that region. Now, this is a nice little representation of this. Now, notice that if I draw a tangent line at a point right here, then that tangent line, notice that it's positive, and in this region, this function is going up. And it will continue being a positive slope for that tangent line up until you reach that point right there. And at that point right there, notice that you have a horizontal slope. There you go. That is that horizontal slope there. But notice that beyond that, the function is at that point starting to decrease. It's going down from left to right until you reach a point down here where the function is, or where the slope is, of course, again, 0. So there you go. Now notice that beyond that point, the slope of the tangent line is now positive, and so on and so forth. Oops. Good deal. Until you reach that point right there, which at that point it will be horizontal again. And beyond that, the function will be decreasing, which means that the slope of the tangent line is negative. And there you go. So, let's talk about something. Notice that at this point, the slope of the derivative is, or the slope of the tangent line is 0. Down here, the slope of the tangent line is 0, and up here, the slope of the tangent line is 0. Notice that this is breaking up what's happening between these. Okay, so anytime you have a positive slope, and then it goes to a negative slope, you have to pass through 0. And anytime you have a negative slope, and then you go up into a positive slope, you have to pass through 0. And anytime you have a positive slope and going down to negative, you have to pass through 0. So what that's telling me is that we have what are called critical numbers. So the critical numbers for a function f are those numbers c in the domain of f for which f prime of c equals 0 or f prime of c is undefined. So we have two different possibilities. F prime of c equals 0, f prime of c does not exist. Two different possibilities there. So a critical point is a point whose x-coordinate is a critical number and whose y-coordinate is f of c. So the critical numbers are where the first derivative is equal to 0 or undefined, aka does not exist. And the critical point is the x-coordinate of the critical number followed by the y. There you go. X-coordinate of the critical number followed by the y-coordinate that you get whenever you plug it in. Okay, good deal. Applying the test. First, locate the critical numbers of or for f on a number line, as well as any points where f is undefined, aka take the first derivative and set it equal to 0 and solve. And also if you have other things that make the function undefined, or the derivative does not exist, then find that as well. These points determine several open intervals. Then choose a value of x in those intervals determined in step A, and use those values to decide whether f prime of x is greater than 0 or f prime of x is less than 0 in those intervals. So basically, is the function increasing or decreasing? And then use the test at the top of the page. Okay, good deal. So that is what we are going to be doing. I'll see you in the next video. Have fun.